So here we are again looking for absolute extrema on finite closed intervals for a function that involves an exponential. There were 3 steps. First, we need to find the critical points. We have the 2 endpoints, but we are interested in any points on the interior of the interval where the function might have a first derivative, g prime, that's equal to 0, or where it doesn't exist. So let's find g prime. This is a product, or you could rewrite e to the x in the denominator and use the quotient rule. I'll use product rule since that's how it's written. F prime g plus f times g prime negative e to the negative x, and that negative is because of the chain rule, the derivative of negative x. So we're interested in where this first derivative equals 0 or where it is undefined. So let's clean that first derivative up a little bit. We have e to the minus x plus x times e to the minus x with a negative. So this is the same thing as 1 over e to the x minus x over e to the x. And that is 1 minus x over e to the x with a common denominator. To answer the question of where this first derivative is 0 or undefined, we can look at the top, 1 minus x, where that equals 0, and the bottom, e to the x, where that equals 0, for the doesn't exist question and the equals to 0 question. So the solution to the first equation is when x equals 1, and e to the x equals 0 never happens. This one has no solution. So we have one critical point 1, which is also the endpoint of the interval. That kind of simplifies our next step, which is to evaluate the original function at the critical points and the endpoint. Since one critical point was exactly an endpoint, we really only have these 2 values to evaluate. The function f, or I suppose we should use the proper notation. This problem's written in g. So g of negative 1 as an endpoint is negative 1 times e to the negative negative 1. That's negative 1 e to the positive 1, so negative e. And g of 1 equals 1 times e to the minus 1, which is e to the minus 1, or 1 over e. Since the critical point 1 showed up here as an endpoint, we didn't have to test any other points on the interval. Now we simply have to make the decision which one is the absolute maximum and which of these points is the absolute minimum. Well, the first point, at negative 1 we get negative e. That thing is a negative value, so he must be the minimum. He is smaller than any positive value, like 1 over e, so that must be the maximum. That means the absolute maximum happens at 1 over e, and the absolute minimum happens at negative 1, negative e. And we've answered the question as presented.